ASN TestBench extends the capabilities of the ASN Filter Designer's signal analyzer by providing developers with a safe sandbox environment for testing and validating filter designs before deployment. This functionality is extremely useful for IEC compliance testing and simultaneously comparing the results of 2 or more filter cascades in real time. This provides a quick and easy way of optimizing designs before deployment. Looking at the tool's existing signal chain, it can be seen that there's only support for one filter signal chain, which doesn't offer much flexibility. Therefore, ASN TestBench extends the capabilities of the signal analyzer by providing access to the internal signal chain and signal generator. As such, a specialized test waveform can be injected into the cascade or even used with multiple filter cascades to perform objective comparisons. The technology used for this dynamic scripting is based on .NET's Code DOM, allowing developers to implement and run short test scripts supported by our DSP libraries. Note that the elegance of the solution is that it's flexible enough to add extra algorithmic functionality to the data streams, meaning that more application-specific tests can be performed within a safe sandbox environment. Examples include being able to perform IEC compliance testing for biomedical and industrial applications. As a majority of industry standard tests are performed with sine waves, we've included a Kalman filtering class to allow developers to automatically extract the properties of a sine wave, such as its frequency, amplitude, phase and DC offset in real time. The DSP library uses the Kalman filtering class as well as other classes and algorithms to provide developers with a rich collection of test and measurement algorithms, as well as supporting all flavors of data types, filters and filter cascades. We've also added a few filter design methods to the library, making it very easy to add extra filtering operations to your testing strategy. The API is clean and very easy to use, as all of the complicated details have been optimized by our developers, allowing you to focus on your testing rather than worrying about details of each test algorithm. Looking at the IDE, we see that it is very similar to ASN FilterScript, but the programming language is C#, which is fast and an industry standard. The interface is very simple to use, and the TestBench class is split up into the following functions. The initialization function is used for specifying cascade settings and other default settings. Looking at an example, we wish to compare the dynamic performance of an IIR and FIR filter using a complex filter for estimating the RMS amplitude of a base sinusoid. These 2 filter cascades can easily be designed in the main filter designer, and then by using the tool's C# code generator, we can simply copy and paste the cascade configuration into the IDE for direct use. Looking at the other functions, we see that the signal generator function gives us direct access to the tool's internal signal generator output. The input data may be overridden if a specialist waveform is required. Notice how easy it is to set up a test waveform comprised of 4 sine waves for harmonics testing. The main function is where the main processing occurs, and you can add as many filter cascades as required or even extra algorithmic operations within this function. Note that the tool's signal chain supports complex data. If complex data analysis is not required, which is certainly the case for many IoT applications, we can use the real and imaginary components independently for our time domain analysis. This means that we can easily perform a real-time comparison between 2 outputs. As we're just interested in the amplitude results from each filter cascade, we can assign the results for the IIR to the real component, and the FIR results to the imaginary component, like so. Also, notice that you can easily post messages to the output window using the string format command. These messages can be customized as required and can even be written to a text file for logging. Compiling the code and running the script, we can see the results of the 2 filters and the input data in the signal analyzer. It really is as easy as it looks. There are of course many other pearls within ASN TestBench, such as the ability to modify algorithmic parameters on the fly, and access to our DSP support libraries, including support for IEC compliance testing. We'll cover these aspects in future videos, and I hope that this overview has given you a good idea of the concepts used in our ASN TestBench add-on. Leave your comments in the section below and let us know what you think. Many thanks, and I'll see you next time.